Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. This episode of the podcast is brought to you by Nexus Pro. Nexus Pro is an annual or monthly subscription where members get exclusive writing, podcasts, and invites to members-only Zoom gatherings. You can find info on how to join and support the podcast at nexuslabs.online. Without further ado, please enjoy this episode of the Nexus Podcast. Episode 50 is a conversation with Shaun Cooley, CEO and founder of Mapped, a startup focused on the data infrastructure layer. We talked about the value proposition of having that independent data layer and the downsides of not having one. Then we took a bit of a deep dive into Mapp's approach to that layer and the keys to doing it really well. Finally, we talked about the real definition of a platform and Mapp's take on the platform concept. Without further ado, please enjoy Nexus Podcast episode 50. Hello, Shaun. Welcome to the Nexus Podcast. Can you introduce yourself?
Sure. I'm Shaun Cooley, founder, CEO of Mapped, data infrastructure company for industrial and commercial IoT.
All right. Thanks for joining us. Can we unpack your background a little bit? So we'll obviously get to Mapped in a minute. Tell me about your career before Mapped.
Yeah. So only career, right? You don't want to know like where I was born, how I was raised, none of that.
Whatever you feel like divulging to the people.
Yeah, no. So I spent 18 years at Symantec as a distinguished engineer in the Norton Group.
Distinguished engineer. Sorry to interrupt.
Yeah, no worries. So it's sort of the second from the top of engineers. It's distinguished engineer. We used to joke that distinguished is one step before extinguished, but it's sort of had, you move through, at least in most, they have different names for it, like 1, 2, 3 at some companies, or Symantec was like associate software engineer, then software engineer, then senior software engineer, then principal, then senior principal, then distinguished engineer, and then eventually fellow. But I left there after 18 years and went to Cisco, was the vice president and CTO of the Internet of Things group inside of Cisco. Mm-hmm. Obviously, Cisco's IoT practice is focused on commercial and industrial, and so nothing residential or consumer. And then left there in July of 2019 to start Mapped, just before we all got to stay home for COVID.
Yeah, totally. Yeah. I was looking at your LinkedIn. I want to ask you a little bit about Cisco, but first I saw there's like something like 100 patents or something. Can you expand on what that means?
Yeah, so all those patents are largely software related. There's a couple of hardware patents in there, but a lot of the big tech firms incentivize the filing of patents, finding novel things that you've created inside of the software and really pushing to file those from intellectual protection standpoint. Luckily, I've never worked for a firm that sort of weaponizes any of those. Both Symantec and Cisco, I use them for defensive purposes. Only it's sort of that mutually assured destruction. Like Microsoft's never going to sue Cisco over patents because Cisco has enough to sue back, and so they just both stay at arm's length. I think that software patents are an interesting way to publicly document the things you're working on at companies where you can't otherwise do it, right? A lot of the work at a Symantec or a Cisco is really internal and sort of protected. And so when you get to publish a patent and file that with the US Patent Office, the work becomes open, start to talk about the sort of architectures and things that you put together that led to novel solutions.
I see. Cool.
It's fun. And I think it's 121 just to...
Oh, sorry. Cool. And so what were the types of things that you were up to when you were in the IoT group at Cisco?
Yeah, so I was responsible for standards inside of Cisco for IoT related things. So whether it was Open Connectivity Foundation, work that we were doing at IETF, 3GPP, all those things on the IoT side fell under my team. Then there was a lot of ideation and planning of where the product roadmap goes. The sorts of things that we're interested in building. And as a very large company, there was obviously a lot of customer interaction. And so, it's an interesting where I eventually landed on the things that we're building now with Mapped But this concept of the way that Cisco sells products is through something called executive briefings. We bring in the CIOs and chief digital officers of these major Fortune 100 companies, and we tell them all the great things we can put into their 19-inch rack in their very clean, air-conditioned data center. And I think when we were working on, it was my third meeting after joining the IoT team, we were doing one of these executive briefings for a major oil company. And the guy we were selling to says, "You've never been out on an oil rig, have you?" And all of us in the room were like, "No, why?" He said, "Feel free to come down to Texas and we'll fly you out to the Gulf of Mexico and show you some of the hell that we put up with on these oil rigs from an automation standpoint." And that really led to me spending a lot of time going out and visiting customer sites. I would, throughout my time at Cisco, take any customer up on an invite to go visit their site. So it didn't matter if it was the roof of a commercial building or a mile under the earth in a mine up in the head of a wind turbine, oil rigs, oil refineries, energy plants, anywhere I could go, manufacturing floors, I would go take a look and see what all the pain was that they were going through with the automation environments. And I think I learned very quickly that it's not a data center, right? It's very different from everything else that we look at on the tech side.
Totally. Cool. So, and obviously a lot of our audience will not be familiar with the things outside of buildings, but those
Sure.
same insights happen obviously in a boiler room. Yeah, exactly. So, okay. So you're at Cisco, you said, "I'm going to quit and start a startup." How did the founding of Mapped work, and why'd you do it?
Yeah, so I think that, I guess I should probably describe what Mapped is before I talk about why I decided to go chase after it. So this concept of data infrastructure, I think that we've called it many different names, and I should give Joe over at Montgomery some credit for the data infrastructure term, although he'll probably never let us live it down. But we were calling it data aggregation layers. I think you call it the independent data layer. There's a lot of different names for this. When you have these environments where many vendors over long periods of time have come in with whatever bag of tools was available to them at the time and built out automations to serve a purpose, right? That the purpose is control of an environment, whether that's manufacturing or oil and gas or commercial buildings. The work that an MSI does is largely the same, right? I've got an end outcome that I'd like to achieve. I've got this set of tools. How do I piece these tools together, and how do I do the programming to achieve that end outcome? Now, fast forward through 50 years of that happening with thousands of system integrators and many thousands of vendors and hundreds of protocols, depending on which vertical you're looking at, now have a situation where you've got building owners, operators, and tenants that are looking at hundreds and hundreds of locations that were all built in different eras by different system integrators from different components on different protocols. And they're trying to make sense of everything from energy spend, how they do maintenance and operations. Pick any big name tech company. They probably have somewhere between 200 and 1,000 offices around the world. If you do the math on that, they're spending about $1 billion plus a year on real estate. And in most of those cases, all the costs of equipment maintenance, energy spend is passing through to them as well. And yet they have no visibility into how any of those systems are running across a portfolio. And so when you look at this, the same thing applies to manufacturing plants. The same thing applies to oil and gas. Each of those refineries was built at a different era with different systems and different capabilities and different technologies. And so now, as you try to get intelligence out of it, the biggest hurdle that we see again and again is integration, right? Going in, mapping out all of those systems and trying to discover make, model, firmware, what protocol does it speak, what are its relationships to other devices, what's its function inside of the environment, what explicit logic does the PLC have. When you start putting all these things together, you can spend a couple months inside of a single commercial building. You can spend a year or more inside of a refinery or an energy plant or a manufacturing floor doing this. And so the company name Mapped is really a play on the mapping process that would normally be done inside these environments. And the fact that all the vendors that we see that deliver software or some sort of value into those environments today, they tended to start out with a handful of data scientists or software engineers. And then if you fast forward a couple of years into the life cycle of these companies, they're like a handful of engineers and 50 integration engineers who are going in and doing the installations in each one of these. And so I think that the insight that I had was that if I can find a problem where there's 20, 30, 50 integration engineers in every one of the vendors that's serving these space, it's time to abstract away that problem and really make it a single sort of layer that can drive that value, so that you don't have to go spend 50,000 non-recurring engineering to do that first integration. You don't have to spend 3 months doing the integration. You can do it in sort of a plug and play type model. And I think at the same time, we were also seeing similarly complex industries being sort of, I would say, unlocked at scale from an innovation standpoint through APIs. And so if you look at credit card processing, you've got a company like Stripe, like nobody in their right mind anymore builds their own credit card processing platform. Right. And you can look at something like text messages. I over the years have built far too many direct integrations into carrier SMS gateways. Every carrier had a homegrown SMS gateway. They were entirely like built by the carrier, operated by the carrier. You had to sign an agreement with the carrier. You had to know how to speak to their particular SMS gateway. You had to maintain a database of phone numbers of like, okay, James's phone number, is that owned by AT&T or T-Mobile or Verizon or Sprint? Because I have to send it to the right gateway. I can't just send it to one of the gateways. And so then you get a company that comes in like Twilio that says like, look, all the complexities, all the sort of historic complexities that have existed inside this environment can be abstracted away through a very simple API. Just send a text message to this phone number. Like, I don't care about all the plumbing underneath. And I think when you put together sort of the challenges and the amount of people that were being spent on integration, or still are being spent on integration, with the fact that other industries have been being solved through a simplified API, and happy to come back to the difference between like an API and a standard later. The fact that other industries were being solved with an API, it really made sense to create this sort of single layer that takes on all the historic complexity and abstracts it away into that API so that everyone doesn't have to keep repeating the exact same task over and over again.
Absolutely. Cool.
I don't know if that answered your question. I don't even remember what the original question was.
No worries. No worries. I love the way you described that layer. It's very similar to the stuff I've seen on your website and other places where you've kind of laid out the problem in a way that I really like. So the original question was, you were at Cisco and you saw this need.
Right.
And
yeah,
I want to hear like a story around like deciding to quit your job, recognizing this from a technology standpoint and a business opportunity standpoint. What made you go start the company?
Yeah, look, I think that you can obviously do a lot inside of a company like Cisco. There are significant resources inside of a company that size, and significant go-to-market capabilities and other things around it. At the end of the day, I sort of looked at, I've been in large tech companies for the better part of 25 years at that point. And I really had always kind of wanted to go do a startup because I hate myself or something. I don't know what the actual reason was for it. This seemed like a big enough opportunity that it was worth going out and pursuing on my own, rather than trying to build it inside of a company like Cisco. Mm-hmm.
Got it. Cool. So that was what, a year and a half ago, almost 2 years ago now?
Yeah, almost 2 years ago. Yeah, coming up on that.
Cool. So where are you guys at today before we kind of dive into the nerdiness? Sure. Where are we at in 2021, spring 2021?
Yeah, so we spent the first 18 months or so building the platform in stealth. It's one of those weird startup things. If for anyone that doesn't know what it means, it just basically means like we had no website. We weren't publicly talking about it. We had a couple of early design partner, kind of early customers that were helping us answer some of the questions around what works for them, what doesn't work for them, what they would want it to look like. And we came out of stealth on March 2nd. So it's still fairly recent, about a month that we've been out of stealth, and really started telling the story of what the company is and how we think that data integration layer really solves a major problem, not just for commercial real estate, but also for manufacturing and industrial environments as well.
Totally. Yeah, I have this opinion that I haven't talked about very much, that I wish more companies in our space would just stay in stealth mode a little bit longer.
I don't know if I should take that personally or not.
No, I haven't seen your product, but I have seen a lot of other products that are what I would call marketing led versus product led. And anyway, that's all I'll say. So let's dive into it. So from where you're at today, you said you've co-developed with your clients. And so I feel like you probably have a lot of opinions about how this layer should be done. So, which is fun for me to dive into. So let's just start with like, you kind of hinted at a lot of this when you described what Mapped is, but like, what are the downsides of, and this is kind of like where we're at as an industry today. We don't really have this layer deployed at scale. So from a smart building standpoint, we have all these, what I would call point solutions deployed, and they're gaining scale, and we don't really have this layer. So what are the downsides of not having this independent data layer, and what will this enable when we do have it deployed?
Yeah, look, I think the biggest downside of not having this layer is that it leaves the sort of final integration of literally everything you want to put into the environment to that integrator that has to show up and figure out what's going on inside of your environment and how to really make sense of it for the application or for the hardware that they're putting in. I almost equate this to like if buildings didn't have a standard size of door, how much harder would it be to go out and get a door for everything? And yeah, there are a few doors that are like wacky sizes, but in general, that sort of 8 foot by 3 foot size you can get from anybody. And it's been standardized. And similarly, the sort of position of a lock on a door, the size of the hole, the 2 3/8 inch hole that you need to drill, all this stuff has been standardized, but yet our building systems are just all over the place today. And I think that we continually pay a penalty for it. And we've almost sort of accepted that it's just okay to go and spend 3 months integrating everything that we want to integrate into the building. And I don't agree that it's okay, right? I think that we need to have that layer that abstracts it away. And so the penalty of us not having it is that we continue to waste time on integration. We have a very strong belief, which is right here in my background, is that we want everyone else to focus on innovation and not integration. You shouldn't have to spend 30% of your time like doing that final step of integration when you should be spending it on building cool new stuff or new analytics or new carbon credit trading or whatever it is that you have in mind should be where you get to focus your time.
Yeah, and I would add to that and say like just like Stripe and Twilio kind of handle all of the ongoing mess that happens as well. So there's, as someone who's done this integration before, there's often upkeep, and it's not just a one-time set it up, now we have analytics, or now we have this perfect new smart building application. There's always like this, someone unplugged the thing from the switch, someone decided to close that hole in the firewall just to see if anyone would say anything. Like these things happen all the time. And it's also the just like someone handling it, right?
Yeah, we refer to that as the day 2 problem.
Okay.
Day 1 is like you got everything working, all the data's flowing, it's like whatever your transform layer is working, you're feeding the applications, and then day 2 happens and it broke. I don't know why it broke. Let me go back into the building and like figure out what happened, where the data stopped flowing. And that day 2 problem is a real challenge. I think, so we refer to it, and we can get into this more later, but we refer to it as a living graph. And the graph representation that we have is living. It continues to evolve over time. And so the APIs, the way that we describe it to our customers, is really meant to be sort of self-discoverable. You don't need to have prior knowledge of the environment that you're going into in order to sort of traverse the graph and make sense of it. And that allows us to like continuously incorporate change and what we call enrichments into this graph so that the developers who are building on top of it can continue to benefit from that, right? And again, like as a software developer, you don't want to, like if Twilio can't send a message to AT&T, like not my problem. Queue it up when AT&T's back online, send it to them, right? Like I don't care about what your internal issues are. That's not my problem. And similarly, we want our customers to not have to care about a firewall port closed, or somebody upgraded the firmware on a device somewhere, or swapped out a controller with something else, and like everything falls over underneath, right? That's our problem to go figure out and to continue to update the living graph.
Absolutely. So thinking back on the history of like the building owners I've worked with, and correct me if I'm wrong here, but it seems like there's two types of building owners when it comes to you guys approaching them. There's people who get it and the people who don't get it. Like, and what I mean by that is like, I can remember like I spent a long time with healthcare clients, and it was a big stretch to get them to get to where they see the value of and this was just this certain type of healthcare client. I'm sure there are healthcare, systems that do get it. What I'm saying is, like, to talk to them about an independent data layer and sort of make the business case would have taken years. And so we often would just go in with a complete solution, right? Or maybe not even talk to them about it. It's just kind of in the background. And then there's the people who like have been out there deploying use cases for a long time, and then they see, oh wow, I really get this now. I need this. Is that sort of how it is when you're out talking to building owners?
Yeah, look, I think when you put it in that simple of buckets, it absolutely, they fit into one of those two buckets, right? Either they get it or they don't. I think that we look at the go-to-market in a couple of different ways here. The sort of the easy ones are the tech tenants. Think of all those big, like, Fortune 1000 tech companies who manage the large portfolios. They internally have data science teams and BI teams that are capable of making use of an API or building, applications that make sense for them on top of the API. And they're also managing the large portfolio, which means that they've got a desire to go after it. I think that when you get into the owner and operator side, there's a very clear delineation between the very tech forward owner operators and the sort of not so tech forward owner operators, right? We talk to a lot that they literally take over a building, they upgrade the lobby, the marble in the lobby and the elevators, and they try to release out the space for a little bit more and flip it to somebody else.
Yeah.
Like they have no interest in the control systems other than that they're not starting on fire, while they're trying to sell the building to somebody else. And I think that for us, that obviously creates a little bit of a challenge as we go after that longer tail of the sort of non-tech forward ones. But what we'll find over time, at least what I believe we'll find over time, is that as we reach a critical mass of buildings where the third-party developers start making use of it as well, those third-party developers are not just selling an API into the customer. They're selling some value, some business outcome, some energy optimization or predictive maintenance solution into those environments. And if they're depending on us under the hood to make use of the APIs, now it starts to make more and more sense to the buildings. I think on the tech forward building side, we hear a couple of different things. Either they've been struggling for a couple of years to get together their whole portfolio into a single data lake or whatever you want to call it. And they've been struggling to normalize data. They've been struggling to capture data. They've been struggling to make use of that data. Or they just sort of have this like vision of like, it'll be solved soon. And so they're looking for a vendor that can do it for them. I think in both cases, our conversation's pretty easy with these customers. You've got a lot of buildings that all have a lot of data. You're trying to get access to it. We can help you, right? We can give you a very clean API and way to do that. The next question then is like, what do you do with the data? Again, if they've got a BI team or a data science team or even a finance or ops team that's capable of using the data, there's a very clear path to immediate use for that. The ones where we find no BI or ops team, we see one of two things. Either they have a vision for, like, we've had one tell us that every building should have an API and that no vendor should ever be in the building again, right? Like if you want to sell me a software package that runs on my building, like go use the API and talk to me when you're using the API. You're not crawling around my space and putting boxes in my space and like adding additional plant pressure that might eventually cause something to fall over and stop working. And that model, I think works really well for us, right? Having a cloud API that brings together all your data, where you get the visibility and control of where the data is going and who has access to it, is a good story for that single API. The other one is like they have tenants that are demanding access to data, right? And so when the tenants start asking for building data, it tends to be those tenants that are in many locations around the world, trying to sort of quantify where their dollars are going on that space. And as a building engineer, when a tenant comes to you and says, we want access to building data, like your first answer is like, what? I don't have a clean way to give that to you. And yet we're seeing more and more of these tenants signing leases where the lease actually mandates access to building data. And they just don't have a way to give it to them. And so in some cases, even though there's no BI team or data science team that can make use of it in the owner or operator, they know that there's demand from their tenants and they're viewing this as a tenant service that they're providing, which is, we can give you access to the building data for your floor with like a simple API that you don't need to go and spend a bunch of engineering effort to try to provide. So I like the sort of they get it or they don't, but I find that there's a lot of shades of gray on that.
There's always nuances. Yes.
Like, yeah.
Yes. Yes, definitely. So how about other vendors then? So one of the things that we talked about last week at our pro member gathering is like, it probably actually makes sense to then like sometimes not go to a building owner with this, go to a vendor and partner. And I think there's also probably nuances and shades of gray there, right? Where it's like, it seems like some of them would probably not want to give up parts of their stack. Can you talk a little bit about why a vendor would want to bring you in and say, well, I want you to take care of the integration piece?
Yeah, so I think that there are a couple, again, many shades in here. So it depends on the type of vendor we're talking about. If you're talking about an MSI or an MSP that's going in and performing services inside of these buildings, many of those MSIs are looking for ways to do sort of recurring revenue type services in the space. And a lot of those, you can think of anything from like a remote management of buildings, remote optimization of buildings, where they're not just sort of watching it remotely, they're also helping you to maintain things remotely without having to show up on site and do things. For a very large portfolio, a mid to large size MSI, every one of those buildings is a slightly different environment again. So just like those companies that are in a bunch of buildings, like you're dealing with the same thing as a vendor to that space. You have to send somebody out to go figure out what's going on with the system, or to tell them that like some set point is off and it's costing them a bunch of money. Those sorts of investigations right now require that a human goes out and visits it, which means you've got to have this like fleet of humans that you can send out to all these places. And so as they look for ways to move from services into recurring revenue, they're very interested in finding platforms that make that easier for them. I think that the other one is that you'll probably see some of the MSIs start to build applications as the access to data gets easier and easier, right? They will start moving up the stack into some of the application spaces, some of those analytics and other types of services that they used to provide with humans, but no longer focused on the integration piece, but rather the sort of data use piece. When we get into the application vendors, the folks that I think like last week we had Clockwork Analytics on there, right? Those sorts of folks, I get a mix. I've had, apologies for language, I had one of their CEOs tell me, I don't ever want to install any more shit in buildings, right? Like they just, like, they want to do the data science problem. They want to add value and provide a benefit to the customer. And the integration is viewed as a sort of necessary. They had to go in and do the integration in order to provide the value that they sold to that customer. Yeah. They didn't want to do the integration, they had to, right? And so I think in those cases, similar to the same sort of like cloud discussions that we used to have of like, well, yeah, you can go rack and stack your own servers in a data center somewhere, but like, why? You can just use Amazon or Azure now. Like, why would you ever go rack and stack your own servers again? I think that eventually we'll get to a point where, whether it's us or somebody else manages to get to a large enough deployment where there will be a vendor in there where it's like, why would you ever go bother? It's the Twilio one again. Why would you ever go bother to send your own text messages just because you can, when it's not the part of the business where you're adding value? And so I think that we'll see the vendors shift over time towards API platforms that normalize for them so that they can move away from that NRE, the sort of non-recurring engineering that they spend today on integration. Oftentimes that's either directly billed to the building as a upfront installation or integration cost. That can be pretty significant in many cases, or it's rolled into a 36-month contract that they sign. The building signs like this 3-year agreement for whatever software they're installing, and the vendor just hides the cost of their fees into that, right? I think if you can switch to an API where you're paying a couple $100s a month rather than $50,000 up front, and you can just start making use of the API as necessary, it makes it a lot easier to scale a business out. It makes it a lot easier to not have to ramp up an integration team that goes out and does the integrations when you can just depend on an API being there to handle those cases for you.
Totally. So what's that look like for you guys then, as you look to go to market and to scale up? You guys are then taking those, like you said, those 50 engineers that everybody has and pulling them internally. So what's this look like for you guys and for you as a CEO? Are you looking for, 50 of your own integration engineers right now, or what's your
Yeah,
plan
so,
there?
look, I'm always looking for smart people. I think if anyone knows this space really well and wants to come work for us, I'd love to talk to them. We view this from a very different approach, and that is that this is not a job for people. And I realize it is today. And so if you look in other industries, if you look at something like enterprise asset management on the IT or the IT security side, these sorts of things are largely solved and have been for the last 20 or so years, where you install a piece of software, it goes out and discovers everything on your network, and it figures out the make and model of those things. And in many cases, then they go into like, what's its security posture? Does it need to be updated? That sort of stuff. In our case, we use automation and machine learning to largely do those same things. We go out, we discover all the things on the network, whether it's a serial bus or an IP network. And we're doing that to find its make and model so that we know how to map it and model it inside of our graph. And once we know how to map it and model it inside of our graph, then it turns into how do we operationally extract data from it. Right? We want the data that continues to flow out of it. We use a bunch of different techniques to get data out of those. Some of them are active. We're actually like pulling devices for data. Some of them are passive. We monitor traffic moving across networks and look for protocols that we know how to speak and pull apart those protocols. And so part of this is like, we don't want to add more load to the systems that you already have inside of the building, right? If you're already hitting some device 10 times a second for some reason, us hitting it another 10 times a second doesn't really help anybody. But if we can pick up on the communications between your existing controller and that device, and we can just read the data that's coming off of it, we benefit a lot from the fact that most of these protocols have no encryption or security of any sort. And it allows us to sort of sit in the network layer and watch what's going on inside of the environment. But we're doing that, again, to produce that operational data that's coming out of there. And then when the data gets to our cloud, all the tasks of merging that data into our graph and mapping it fall onto machine learning. And so we use a lot of ML, some sort of natural language processing on things like point names, but also a lot of sort of deeper ML on how we look at relationships between devices and discover both explicit and implicit relationships between those devices.
So what you're saying is, whereas a lot of people are just kind of hiring a bunch of people like me who I've done this before and I shouldn't have been doing this. Like you didn't mention earlier, you didn't mention the mechanical engineers out there that are out there trying to figure this out. Yeah. Basically just like plugging stuff in and seeing if it works and then calling somebody.
Yeah.
Anyway.
Yeah. I think I reversed the two wires on my serial bus. What's happening here?
Exactly. Yes. Yeah. I always used to call it hacking, and it was just like a mechanical engineer trying to hack the, anyway. Where I was going with that is it seems like another value of splitting up the stack into these different layers is that you guys can then build out, tools that the other people that are doing this in a one-off way don't even have time or desire to do it. So you guys can get better and better. Whereas everybody else, if they're distributed, they're just kind of doing this as a means to an end.
That's right. Yeah, so the system learns globally, meaning that so some of the interesting things that we start to see, we see both sort of regional and, like, if I just look at the point names and our processing of point names, we see both regional and time-based sort of differences in point names. Mm-hmm. What people were commissioning systems with in the 80s in Los Angeles is very different than the 80s in New York, and the 90s in LA. Totally different point naming, schemes than they were using in the 80s. But, as a system that sees globally all of these things, once we train it how to pull apart a single mechanism for point naming, that applies to any other building we come across that was done by the same vendor in that same era, right? And so you start to get a lot of value out of doing the same work over and again across everything. And I think with humans, every human enters every environment new. You've got to go in, get your bearings, understand where all the equipment is, like what's connected to what type of systems are in there, start reading manufacturer documentation. And the manufacturer docs are not particularly easy to go through on a lot of these, especially on the protocol side. I mean, you pick your favorite chiller from Carrier, it'll have a 450-page technical manual. Yeah. And 2 of those pages talk about how it uses BACnet. Those are the 2 pages that, like, we care about. Yeah. But if you're in there doing mechanical design and you need to integrate one of these systems into something else, you've got to go find that 450-page manual. You've got to scroll through it till you find the 2 pages that talk about the piece of info that you care about. Yep. Like, okay, what is the analog input and analog output for this thing, and which one is which, and like, how do I read the value out of it? Is in Fahrenheit or is in Celsius? And
Yeah.
Those sorts of things, like they're very easily solved through sort of big data and machine learning. Because again, every time I come across a Carrier 30 RUT chiller, like it's the same. I don't
Right.
need to go look at the manual again if the system already knows how to interpret the data coming out of that device.
Absolutely. I did that on a project like a month ago.
I'm sorry.
O&M manuals to the death. Yes. Hey guys, just another quick note from our sponsor, Nexus Labs, and then we'll get back to the show. This episode is brought to you by Nexus Foundations, our introductory course on the smart buildings industry. If you're new to the industry, this course is for you. If you're an industry vet but want to understand how technology is changing things, this course is also for you. The alumni are raving about the content, which they say pulls it all together, and they also loved getting to meet the other students on the weekly Zoom calls and in the private chat room. You can find out more about the course at courses.nexuslabs.online. All right, back to the interview. Let's talk about so we're kind of getting into it a little bit, the data modeling piece of it. So what are some of the keys to modeling the data to enable it for whatever use case a building owner wants to enable?
Yeah. So we use Brick. I think we're fairly open about that. Our chief data scientist is Jason Coe, who's one of the co-creators of Brick. And so it would be crazy if we went with something else. So I think that there's a couple of things in play here, right? You're taking data from very different systems, again, configured by different system integrators, named differently, wired up differently, and trying to normalize it into sort of a schema that is representing not just the individual points and devices inside of there, but also the locations, also the relationships between all of these things. Like one device feeds air into another device or has a point of this other device. And then I think the thing that we add that's not quite in Brick yet is people as well. So we track people, places, and things inside of our ontology. And so the extensions we've done should be rolling back into Brick soon for all of those changes. But getting from sort of raw data into Brick takes a couple of steps. I think that the first one is obviously that discovery that I talked about in the building. And then it turns into extraction. You've got to get data out. You have to efficiently get that data to the cloud. And then you've got to start making sense of that data in the cloud. And so we start with something that we call device profiles. So those device profiles, earlier when I said Carrier 30 RUT chiller, if I know how to talk to it, I know how to talk to it. That is what we would call a device profile. Okay. So the device profiles take us from sort of raw data that we've discovered in the building into what we call structural data inside of the graph, inside of the Brick graph. And that structural data, for example, if you took a thermostat, very simplified, the thermostat may have a vertex in the graph, a node in the graph for the physical thermostat itself. Then it might have a set point for the humidity and a set point for the temperature, and a sensed temperature and a sensed humidity, right? Mm-hmm. So in the graph, a simple thermostat may turn into 5 vertices in the graph with 4 relationships between them. That sort of information structurally of like, I found one device, I need to represent it in the graph, we can do through our device profiles. Okay. And those device profiles allow us to do that pretty quickly. A whole nother talk for how we build device profiles some other time. But once we have the structural components inside of the graph, now we have to connect them all up. Right? What is this thermostat actually controlling? And in most cases, that thermostat does not have a direct relationship with any other piece of equipment. It is being either pulled or signaling a controller of some sort. And the controller has some human created logic inside of it. Somebody actually went in and programmed it in order to drive some other device based on the events coming out of that thermostat. And so that relationship data to us is an explicit relationship, right? So there is now an explicit relationship between the thermostat and the rooftop cooling unit or whatever your system happens to be. Those relationships we learn through a couple of different mechanisms, but we do a lot of time-based correlation. And so as we see sort of action reactions happen inside of the things in our graph, we start to draw lines between them. And over time, those lines get sort of more and more confirmed as we move on. And then the last one, I guess the last two, is a mix of sort of geospatial. How do you represent geospatial constructs inside of these environments? Somebody went on a rant during the last member call about mapping data. It might have been Steve, like how hard it is to get floor plans in these spaces. And so part of the geospatial, there's a couple different ways we do geospatial. We use some public data sources to get the outside footprint of a building, right? It's pretty easy to get the outside walls of a building. That at least gets us sort of longitude, latitude in large sense. Then we allow the customer to either upload PDFs or AutoCAD files, or if they've done a 3D scan of their space that either has gone into Matterport or into Leica TrueView, we can actually connect to those and pull a slice out of it as well to get the indoor maps. But now, as you're trying to place devices throughout those spaces, you run into a couple of different things. One, point names that were commissioned in the 80s likely have no relation to what the current name of that space is. So when the current tenant uploads their map and it's got a conference room called like Frontierland, and in the point name, it's like RM624, how do you link those things up, right? And so we start looking at correlations over time between systems that we know where they are physically, systems that we don't necessarily know where they are physically, and it allows us to start moving things closer to each other. We do also at any time, an administrator can grab a device and just drag it to where it needs to go so that we can stop trying to guess on it, but we do try to make pretty good guesses about where things go.
So there's like a user interface piece that lets someone that doesn't know anything about graphs sort of update things.
Yeah, our user interfaces, and you can see it on the website, it's very much focused on the visualization and control of your data. And so we do a couple different things in there. And then, and I'll come back to that in a second. On the last piece, the last thing that we do is enrichments. And so we look for signals coming out of the data that we can further enrich with sort of more meaning. It's not, I don't want to call it analytics because it's not quite, it doesn't replace the analytics that an application vendor would build on top of us. But if you take something like a Cisco wireless access point that's tracking the movements of mobile devices moving around a space, right? You can get the same thing from like Euclid Analytics used to do this before, wherever they went inside of WeWork. But like Meraki has it, Ruckus has it, Aruba has it for the wireless access point. If two mobile devices are always within a meter of each other, there's a pretty good chance we can introduce a person into the graph, right? Those two mobile devices aren't just moving in unison on their own. It's likely that there's a person that's moving around with them. And so now that concept of a person gets you to much more useful information as a developer. And again, without that extra step of having to try to figure out that correlation between those two over time, because we're doing it already inside of our graph. And so we do a lot of enrichments like that look at things like correlation between multiple devices over time in order to introduce new concepts.
Okay, cool. So you mentioned extending Brick and sort of updating the standard after that. So like, it's interesting that you said that because not a lot of people do that. So what's that process look like? I guess having Jason as an employee.
It's helpful. It's definitely helpful. So the Brick Consortia is still being formed right now. I don't know how public it is. I won't say company names, but there's several very large building system companies that are forming this Brick Consortium around it. Jason and Mapped will obviously continue to be involved in that. Really Jason on behalf of Mapped. And so internally, as we come across more and more systems, what we find is that Brick, I think in the like 0.9 or 1.0, they went really deep on HVAC. They covered like every possible construct in the HVAC system. And then when they went to like 1.1, they introduced a lot of energy management and lighting type things in there. 1.2 that just came out, again, further extended it in a bunch of other directions. And so as Jason gets to spend time and as other members of the future Brick Consortium get to spend time, you're really thinking through some of these other systems and how to appropriately model it inside of these graphs. We will contribute back. Our view from a standard standpoint is that Brick is pretty well ahead, and not to bring back up the standards wars, right? But we think Brick is pretty far ahead of the other standards out there as far as modeling relationships and all the actual things inside of a building. The other part of it is that Brick is very prescriptive. It is very clear about how you represent certain things inside of that. And some of the other sort of semantic tagging type standards are not so clear about it, right? And I think when you look through them, what you find is that there are a significant number of sort of standard tags, but then when you go into an environment that makes use of it, they had something that they wanted to represent that wasn't available in the standard, and they just like made up a tag. And as soon as you do that, now you're back to sort of custom meanings, custom names that don't really make sense to anybody else. And it's really hard to enter some of those environments with no prior knowledge and figure out what's going on inside of there. And so for us, Brick is the appropriate way to really have a self-describing environment, where as a software developer, I don't need to know in advance what I'm targeting. I can just sort of show up, look at the model, and understand how these things work together and what the data is that's coming out of them.
Totally. So let's talk about the data model piece. I want to get into APIs in a minute, but extending the data model into the use cases that it enables. So I think there are a certain number of, say, software application companies out there that have the opinion that you can't separate the data model from the use case or the data model from the application that sits on top of it, because inevitably, if like your data model is not going to have enough information, or it's going to be wrong and it's going to have to be redone. So what do you say to that opinion?
Well, I think, I think first, every database and operating system vendor on the planet would disagree with that statement, right? Like, I think we have seen again and again that a platform is capable of supporting many disparate use cases and things that the platform creator didn't think of at the beginning, right? This is sort of the benefit of a platform. If you took an Android phone, right, and every vendor of Android phone with a different camera, different GPS unit, different CPU required me as a software developer to code directly to that GPU, or to that GPU or the GPS or the camera, I think we would have like 2 apps running on all of our phones. And the fact that like somebody has abstracted away all that complexity into a well thought out API means that it's very easy for a software developer to build an app that makes use of the camera or makes use of the GPS or makes use of some other component inside of there. And I think that Brick is enough of a standardized model without really changing what the origin meaning is, right? In that I can represent a thermostat or a set point temperature or a set point humidity and have the values that go along with it. And as a developer, I can understand that at scale across a large portfolio without needing to know, like, is this the camera from Sony or is this the camera from, right? Like, similarly, I don't want to know if the thermostat was built by Honeywell or Johnson Controls. Like, just give me the value that was inside of it. Like, that's all I really care about at the moment. And so these sorts of arguments, I think, in the tech space, and this one, I think it is a side effect of what's typically referred to as the stack fallacy, right? Which is that it's always easier to move down the stack than it is to move up the stack. But what's important to keep in mind is that a platform vendor, if you take an Intel who's making CPUs, they don't need to know what the application that's being built on top of the CPU is in order to provide a very sort of usable and broadly applicable CPU. And I think similarly, as a vendor that's trying to take all of these disparate systems and represent them in a uniform way, I don't need to know what the application up stack is. And now, I think the stack fallacy is totally valid. If we tried to move up stack, if we as Mapped tried to go after the applications, after the single pane of glass, after the energy optimization or carbon credit trading things, like, I don't have the first clue in how they sell those to customers or what the sort of value that's promised is. But from here's chaos, I can provide normalization. I have a very good idea of how to provide that normalization layer in the same way that a CPU vendor can figure out all the possible instructions you might need and make those available through the sort of code that you would put onto that execute inside of that CPU.
Totally. So let's talk about the API. Everyone talks about an API for your building. Maybe it's just in the Nexus community, but I say everyone. What I really mean is the nerds of smart buildings talk about an API for the building. So what are the sort of the keys for an API for a building?
Yeah, I think maybe I'll start a little higher level than that. I think as modern software engineers, you look for a lot of things from an API. You're looking that you can use a modern programming language to access it, that you're not really having to deal with the transport layer that happens underneath it, or the physical layer that happens underneath that. And I think today, when you look at something like a BACnet or a KNX, like, those things become very important, right? Is it over IP? Is it over serial? What's the speed of the bus that I'm on? I see all the time, like, even on the IP side of things, the NIC in the controller is still only 10 megabit, right? And it like brings the whole network to a crawl. And so these sorts of things, as a modern software developer, like, I don't even want to deal with trying to get into the building. the firewall that the building has, or does the building even have a network, or is it individual tenant networks that are inside of there? And so it starts with like, it should be accessible everywhere. And we look at this from the cloud standpoint, right? Like an API should be available in the cloud. I don't need it to be in the building. I don't want it to be in the building, because that's not the place where you're really trying to get access to everything these days. And so it starts within the cloud. Then the next step is, can we use sort of modern technology to access that API, right? And so we use something called GraphQL. It was created by Facebook and has been proven to be able to handle very large graphs and pretty complex queries across that graph. We've extended it in a couple of different ways. So if you think of Brick is the structural representation of everything that was inside of the building. It is not the time series data. The individual time series points still have to be stored somewhere else that is not Brick. And so in our graph, every vertex in the graph has a time series store behind it. So if you look at like the set point temperature vertex that thermostat had that I talked about earlier, there is a time series store behind that where I can also get the data from that vertex over time. And so we make that available in a lot of different forms. You can get it in raw form, which is just, I want the values wherever they happen to occur. We can do it in aggregate. So give me the values over the last year by month, or give me the min, max, and average by month, or give me just the max on a minute by minute basis over the last 2 hours. Those sorts of queries drive a lot of flexibility in the way that an application developer starts to make use of the data. I think that from a Brick standpoint, and Jason will disagree with me, but RDF, which is the relational data format that is sort of the driver behind Brick, is not developer friendly. It is not something that I would put in front of a typical developer and expect them to understand. I think even when I started working with Jason, probably 6 months into it, I was still asking questions about RDF and like trying to wrap my head around it. And there's this whole community of data scientists that understand RDF inside and out and are building this web of things and all the work that the W3C is doing around the RDF standards. But as a developer who's been writing code for 25 years, it's like, there's a lot of stuff in there that I just couldn't wrap my head around. And so we actually use a variation of it. The ontology is still the same. So if you understand Brick, our ontology is no different. But because we're exposing it through GraphQL, it's a little more developer friendly. It's a little easier to understand the relationships and the hierarchies and how you get from something that was in the structural RDF to the time series data, right? Those pieces are typically separate systems and not easy to connect. And I think that for us also, moving away from RDF allowed us to scale it to a much larger scale than we could with any of the RDF databases that existed out there. And so we continue to own that. But again, as a developer, that's not your problem, right? Like that's my problem in Mapped is like, how do I scale my database? How do I do security? How do I do all the other things on it? And so GraphQL, Brick-based, we allow for both polling. So you can make an individual query into the graph. Give me all the temperature set points as they changed over the last 6 months across my entire portfolio. Pretty easy, right? Like, has somebody been messing with my thermostats throughout the building? Like, I just want to see where the values changed. You can also subscribe to queries. So you can put in what we call a streaming query, which is, here's my query. Every time it matches a value, just call me on a webhook. A webhook is, they've got an application running in their environment. And every time we have this, we actually fire a message out to them as well. So if you think of like in the buildings right now, the controller's like, hey, what's the temperature? Hey, what's the temperature? Hey, what's the temperature? Hey, what's the temperature? We obviously don't want to build that same thing in the cloud. And so you can set a query that says, when this temperature changes, let me know. And so we can use that to sort of push these notifications back out to other applications. And so if you think of something like a dashboard, when that dashboard first spins up, it's going to make a bunch of queries to build the sort of initial view of that dashboard, the graphs and charts and whatever happens to be in that dashboard. And then it's going to subscribe to a bunch of queries. And as values come in, it will update the values in the dashboard. And this sort of a model drives this use where the dashboard that you leave up on a screen or that you leave open in the background on your laptop is not just hammering away at the API and like really like driving a lot of network traffic and other things that you don't really need, right? Because you only care when the value changes. And so, yeah, lots of ways that we think about how to make an API sort of consistent and strong. The other piece that I'll add is that as a building owner or as a tenant of a building, as you install other applications, you start to think about, how is that application using my data? And so how are they using my data shouldn't just be a question. It should be set up in advance in the permissions that you grant to that application. And again, I think that when you look at trying to automate buildings from a control standpoint, it was very easy to say, like, what do we need permissions for, right? Like, it's either on a private serial bus or eventually it's on a segmented IP network. Like, the things are all trusted that were plugged into the environment. But now you're plugging in like vendor after vendor and application after, and like, you don't know who's accessing what or where they're taking the data, if anybody has remote access to that. And so when we move that into the cloud, it's much easier for us at that point to put up a very clear definition of how you grant access to something. And so in our environment, as the building owner or the tenant, if you're installing an application, you choose this application can access my electrical data and my elevators, but not my HVAC. And it can access my entire portfolio except for like these 3 floors that have a federal government customer where they're not allowed to see the data. And so you can be very explicit around how these things come together. And it's enforced at that API layer. So you don't need to worry about how that happens over time.
Cool. Interesting. So how do you think about an API versus standard? You brought that up earlier. Wanted to hear your thoughts.
Yeah, there can obviously be standards that define APIs as well. I think that when we look at, in the case of Brick or even Haystack, right, they're defining a data standard, a way to structure and sort of tag or represent data. What they don't prescribe is how you access that over a network, or how you control access to who can see parts of it and who can't see parts of it, or how you sort of throttle that, right? Like, if one application decides to start hammering your Brick server, like, let's say you've got an RDF server, like a Neo4j or something that you've got all of your Brick schema running inside of, and one of your applications starts making 100 requests a second to it. Like, do you need to throttle that? Who's in charge of throttling that? How do you even notice that's happening, other than the fact that your server is like catching on fire at the time, right? And so an API allows you to introduce a lot of these sort of, I would say, walls around the actual data format. And we use Brick as the data format, but all of those constructs around who has access, how much access do they have, how frequently can they call it, who's paying when they call it, right? That's a big question as well. If I host a server up in the cloud somewhere, like, somebody's got to pay for all the CPU that it's using. Where if I'm hosting my own Brick server and it's just getting like hammered by one of those vendors, are they paying for that bill or am I paying for the bill? Who's doing that? And so I think you get a lot of these where the standard on the data side does a great job of modeling the data itself, but doesn't go, into answering those questions around like, how do you access it and where and when and why and all those pieces.
Got it. How about, this is my last, I think, nerdy question on this layer is and I ask this a lot on the podcast, but like, where are you seeing the market in terms of using this layer for control? So the application wants to send a command back down to the systems. And since you're in the middle of that, what's sort of the state of the art for supervisory control?
So I should be totally clear. Today we are read-only and absolutely by choice read-only. I think that when you've got a data layer like this that is allowing write commands back into the environment and allowing you to install various applications, you very quickly run into contention between those applications. The application that's trying to optimize energy wants it to be 77, and the application that was trying to optimize occupant comfort wants it to be 74. How do those get settled, right? Are those two applications literally just fighting over the value, like back and forth and back and forth? And your systems are constantly like kicking on and off to try to like meet up with the two of them. And so our choice to be read-only from the beginning is because we're working on other things to address that, right? And I think that there are really good ways to address it that don't sort of expose the exact value back to the developer. You can start to sort of, and that's not to say we won't expose the exact value, but I think that in a lot of these where you might have contention, you want the developer to declare their intent, which is, I intend it to be a little bit warmer, or I intend it to be a little bit colder, or I intend it to be a little bit brighter or a little bit darker. And so you can start to sort of reconcile those intents in a platform like ours in order to figure out what the end value should be back in the control system. And so we view control as a future thing for us. We're seeing enough use cases right now where people are just trying to get data, and the data, they're looking, how can we optimize energy? And they're not necessarily looking for the system to go back in and reprogram everything to optimize energy. They just want to know, like, where are we spending? How do we do things with it? I think we're seeing a lot of use cases right now, and I expect them to be pretty short-lived, but a lot of sort of post-COVID return to work use cases around like where are people moving, how long are they congregating in certain areas, what's the fresh air exchange rate in those areas, like how quickly am I turning over the air, when was the last time it was cleaned, like hotspots and not hotspots from an infectious disease standpoint, right? And again, I expect those to be very short-lived, but they're driving a lot of thinking around sort of how do you use data to better the environment. We're also seeing, both in the EU and in New York, these mandates towards energy data. As a building over a certain size, you now have to provide that energy data in near real time to the sort of monitoring agencies so they can figure out which buildings are sort of burning the most power in that space and which ones aren't. And it just turns into a data problem. Like, how do I get the data out and normalized? And so as we sort of go through and address these read-only problems, we'll eventually get to the write piece as well. And today we have a software block that just doesn't allow us to write back to the environment. And it's just to avoid a lot of the contention and other things that come along with writing back in there.
Got it. Very cool. So this might be another, I guess that was a roadmap question. This might be another one around, I've been thinking a lot recently, and I'll sort of provide some context around these thoughts, which is there's this use case around FDD, fault detection diagnostics. You need to then integrate with a work order system. So we have two applications that now need to talk to each other. And I've identified, I feel like it's kind of this same issue that we're talking about, just higher up the stack, where all of these FDD companies, and this is probably the same for a bunch of different use cases, but all these FDD companies are saying, what CMMSs do all of my clients have, right? Okay, now I'm going to write integrations with all of those. And then on the other side, the CMMS guys are saying like same thing, right? So is there an opportunity for you guys to move up to that layer as well? Or are you thinking about that at all?
So we refer to that as data exchange, which is if you think of in a lot of the platforms like ours in other industries, you'll see these bow tie diagrams, right? And it's data very cleanly moving from like a bunch of things on one side into the platform and then back out to a bunch of things on the other side. I think that the data exchange is more of on the right-hand side of the bow tie, data moving from one application to the others. There's a couple of different ways that we look at that. So one of them is in the enrichments that I talked about earlier with the wireless access points, like tracking devices. We do intend to open up our enrichments to allow third parties to put enrichments into the platform and to monetize those enrichments. And so FDD is a perfect example of like, you don't actually want to run your FDD outside of the platform. You want to put it in the platform and then monetize it from anyone else who's making use of the platform. And that's just something like FDD is using so much data that the sheer cost of like taking it out of one platform and into the next, or out of one cloud and into the next, starts to add a lot of overhead to that. And so there's better ways to do that particular example. I think on these ones where you'll start to see an energy optimization app decide that a value needs to be changed, and rather than pushing the change directly back into the building, it opens up a ticket in the workforce management solution. Those sorts of data exchanges are pretty straightforward through our platform, right? There are ways to write back into the graph and ways to pull that back out on the other side. But we continue to look for cleaner ways to do it. And I think as we get more and more vendors that want to do that data exchange, we'll find better ways to do it. I think we also view data exchange as I would say, to unaffiliated parties. And so you'll start to find data inside of buildings that can be shared more generally. Take a parking system, for example. On a Saturday or Sunday afternoon, that building parking lot is completely empty. And so you may decide that on Saturdays and Sundays, your parking data is publicly available. And so you'll start to see other apps in that sort of data exchange start to make use of that publicly available data as well, where you didn't explicitly install an application to make use of it, but you know that there's value to you as a building owner to drive traffic, literal traffic to your building, because you can monetize the empty parking spaces or whatever it happens to be. And we view that as a data exchange problem as well.
So I'm reading this book called Platform Revolution, and those people who've been listening to the podcast probably realize that I've been saying that for a couple of weeks. I'm a slow reader right now while we have the course going on.
By the time they hear this in a month, it'll be even slower for how long you've been reading that book.
Hopefully I won't be still reading it by the time people hear this. But my question around that is like the way that they define platforms in that book, and they're drawing from examples like Uber and AWS and all these outside of our industry type of technology companies, they define it as you have a producer and a consumer and you have network effects, right? So the way you just described that is, it seems like you're thinking that as well. Whereas like the way people say platform in our industry, they're really just talking about just like bringing data into a database and having an application.
That's right.
It seems like you guys are thinking more in terms of like a marketplace and interactions between multiple third parties, that kind of thing.
That's right. Yeah. So we do similarly break it up into data producers and data consumers. From a data producer standpoint, we view sort of on the building itself, you've got the owner, the operator, any sort of maintenance company or outsourced operations company that's coming in and producing data inside of there. You also have tenants of the building, right? So again, if you think back to the building systems, I've got building-wide systems, HVAC, vertical lifts, fire safety, those sorts of systems are building-wide. Especially in high rise, oftentimes lighting is owned by the tenant, right? They came into empty space and did all the build out in their own empty space. And so they oftentimes own lighting. They almost always own access control. They almost always own surveillance. They own calendaring and room booking. And so, when you really run through all the systems, I think Joe and I had an exchange on your Nexus forum of like the number of systems that exist inside of these. And I think we landed on like 80 systems in there. So it was crazy. But, so some of those are produced by the owner, operator, manager of the building. Some of them are produced by the tenants. Then you can start looking at data that's produced by individual occupants, by the humans that are walking around the space, especially so their location information, if you're tracking mobile devices moving around space or maybe badge swipes. You can think of a tenant experience app that runs on a mobile device that's also producing information coming out of there. Eventually you get outside of the building. The typical ones are sort of weather, right? Everyone looks at weather now. But there's traffic, there's geopolitical, geosocial information. The differences in the occupancy of a building on a day where there's a huge protest out front versus a day where there's no protest out front is drastic, right? And so you need to start paying attention to all of these things really across the board. And so we view all of that as data producers. On the other side, when you start talking about data consumers, we start with what we call first-party data consumers. So if you take the building owner, operator, or one of the tenants, and they're putting data into the platform as a producer, and they're also consuming it for whatever BI or data science or finance or ops teams they have. Those data consumers are first party to us, right? It's usually their own data that they're accessing on the other side. Then you move into what we call second party data consumers. And the second party is really anybody who has a contractual relationship with the first party that provides some service to them. So you can think MSIs, MSPs, even the company that does like maintenance, or a company that's coming in and like cleaning the office at the end of the day. And we don't view them, those second parties, as using the data directly to serve the first party. We view them as using the data to optimize their own business. And so if you think of the company that's cleaning offices, take like an ACO, right? That's like tens of thousands of trucks that are rolling out to buildings every single day. If they can understand from an FDD or a predictive maintenance standpoint when they actually need to go and respond to a building, they can start to optimize their workforce. They can roll a truck only when it's absolutely necessary. And now they can do more with less people, right? Or serve more customers with the same number of people. And I think that those second party use cases, there's a lot of just people that serve these buildings that have a real interest in understanding the data coming out of the building as well, because most of them serve more than one building, right? And they want to know across the portfolio, like, where am I needed? What do I need to do? How can I optimize my business? Then you get into third parties. Our view, third party data consumers are really the folks that are producing software applications that sell to these buildings. The reason that we call them third parties is because we tend to be a component under the hood to them. Right? When they go in with their sales team to a Boston Properties and they sell whatever the solution is that they're trying to sell, like, they don't even need to mention that Mapped is under there. Maybe if Boston Properties has Mapped in the building, they want to point it out, like, hey, it's one-click integration, easy to use. But they can go in and sell as their standalone software solution and never mention the fact that we're under the hood. And so those third parties to us are really, they're providing a product to the first party, and that product makes use of the platform as a data consumer along the way. And then we get into data exchange, which we also internally refer to as fourth party, but we never say fourth party because everyone goes, what the hell is a fourth party? And so, but internally we go back and forth on like data exchange versus fourth party. And fourth party is where you can imagine like the municipalities or the governments that want access to data out of these buildings, whether it's real-time energy use. I think one of the most eye-opening things to me is the US EIA, right? The Energy Information Administration, that does this 10-year survey of buildings. It's the same model as the US Census, right? Every 10 years, they send out a survey. The buildings that feel like answering it give them some data about energy use and upgrades and other things. And then it takes them 2.5 years to compile the data coming out of it. I think right now we're still looking at data from the 2010 survey that was released in 2012. The 2020 survey that they did, we won't have the data until 2022 or 2023, which is like, how is this a thing, right? Like, how does it still take? It's like every 10 years we get new data for how the buildings are using energy, how much they've done on upgrades and things like that. And so we expect, just like the EU has started to do, that like the USEIA and other agencies, and even local municipalities and like local governments will start paying attention to data coming out of these buildings as well. And those sorts of like, again, fourth party, I'm just going to stick with it. That's going to be the new phrase, is fourth party. Yeah. So but those fourth party, they don't have any direct relationship with them other than sort of a geospatial relationship, right? Like the building exists in their domain, and so therefore I get data out of it. But you can imagine other use cases like that as well. I talked about the parking one. A Google Maps hitting an API like ours and asking for all the parking spots within a mile radius of us. That sort of a query is because you're within the sort of bounds of the building, right? You're within that 1 mile radius that was defined. And you can also imagine like a first responder who's showing up to the building, having an app that when they first come into the building can give them all the details of the building simply by the fact that they're in the building, right? The fact that you've like now set foot inside of it or like right in the parking lot, you can start to see like what's the current occupancy of the building, like where was the fire alarm coming from, how do I most quickly get there? Can I get floor plans to help me get through the space? Those sorts of, again, fourth party uses. There is no direct contractual relationship with that first party that actually owns the data. It's just, it's because of the fact that you're within proximity or within the sort of bounds of the ownership of that fourth party. And we think that there's going to be just a lot of use cases on that side as well.
Totally. I feel like that's how people should explain data models. Like as a first responder, I want to come in and figure out where the fire's at or where, and how would you do that if you didn't have a data model? Anyway, cool. So as we kind of wrap up here, that was fascinating, by the way. I haven't heard a lot of people explain it at that level before. How are these problems similar in the other industries? Because you guys are not limited, just limited to commercial buildings in your scope and what you're trying to approach. So how are we different versus how are we similar to other industries out there?
Yeah, I think that, so if you look at our website, we also target industrial, which includes energy production, oil and gas, manufacturing, even retail. I think a lot of times it's easy to forget that retail is still a commercial building. There's still all these systems inside of it and similar sorts of, if you're a large retailer that's got 1,000 locations, you're dealing with the exact same headache that a CBRE or a Boston Properties is dealing with, just at a much more distributed scale and far fewer engineers to manage all those spaces. And so I think that when we look across the other spaces, that the reason that we're so focused on CRE to start with is that CRE shell that you get really exists in a lot of the other spaces as well. If you look at a manufacturing floor, it still has HVAC, it still has lighting, it still has safety and security type functionality, fire safety. It still has access control and surveillance and all the other things that you would get inside of a CRE building or a proper CRE building. But then it adds extra things like robotic arms and conveyor belts and other stuff that you need to integrate with as well. So from a similarity standpoint, lots of overlap in the systems. Also, a lot of overlap in the way that those environments came to be. Very similarly, like they use different protocols. Like I don't know of any buildings that use OPC UA or OPC or S7, right? Or some of these other protocols that are used in manufacturing. But you get the same sort of way that systems were built. An integrator at some point over the last 50 years showed up with their bag of tools and managed to put together a thing that kept the line moving, kept the parts going in one end and product coming out of the other. And And so the problems that they now deal with, even if you take a very large like automotive manufacturer that's got 10 or 12 factories within a block of each other, those factories were all built over different times. They were all retooled at different times. There was different vendors. I think similarly, they're dealing with a lot of the folks that really deeply understand those systems exiting the workforce as well. And so there's a lot of sort of knowledge that's just going away day by day. The system integrators that originally built them oftentimes are out of business or got merged into some other system integrator. Somebody else came in and made some tweaks and like changed the things. And so they're dealing with just a lot of the exact same problems. I think where it differs though is the use cases that they're looking at. You can equate like OEE or overall equipment efficiency to some of the things that we look at on like energy usage or energy optimization, sort of commercial real estate. But I think you'll find a lot more sort of human safety type applications that are going into play. You find a lot more quality type applications. And so you're sort of looking at like, what is the quality of the widget that I'm producing? Or an oil refinery, what's the quality of the mix that I'm producing at the moment? We look across and take a major oil company and little things like when they start producing a different mix, like they switch from 89 octane to Jet A, right? And when they go around the refinery and sort of twist the knobs that are the valves that allow them to control how they're producing that mix, there are many times where the first bit that they produce was inaccurately, like one knob wasn't turned right. And so what you're finding is more and more of these refineries now have a central view to see where all the positioning of those are. Whereas before they would radio out to people who oftentimes would go on a bicycle to like out where it was needed to be. And so, but it really is a lot of the same problems, right? Like misconfiguration, FDD, energy optimization, safety, security, those sorts of things. I think when we look at the other industries, though, we get into a lot of just regulatory concerns around how you deliver products into those spaces. There's not a whole lot of regulatory concerns inside of commercial real estate, right? Like if you have like a UL certification or a TUV certification on the product that you're putting into it, like you're usually pretty good to go. Yeah. You go into a refinery with a tiny little box that could potentially spark. The amount of explosive gases in the air at any given time might be enough to level an entire city. And so that you've got to meet like HAZLOC certification. And some of these, like at Cisco, some of these HAZLOC boxes that we had, they look like the nesting dolls, right? Where you've got like your box in the middle in a box. And before long, it's like the size of a car, because if any of those gases get in there, you've got really big problems. And so I think there's a lot of other complications into entering these spaces. Also, from a equipment standpoint, if we put equipment in a building and it has a fan in it, not a big deal, right? You put a fan down in a mine, like you've got a lot of problems. If you want to put something on a launch pad, all your electronics need to be potted, right? They need to be covered in like a silicone that holds them together, because the 190 decibels of vibration while the thing's taking off is going to shake every component off of your circuit board. And so if you get past those sorts of things, the discovery and ingestion and normalization all starts to be very similar to what we're doing, right? We just need different device profiles. We need different protocols that we speak inside of the environments. And for us, Brick needs to continually be extended to all of these other types of equipment that can exist and types of relationships in these other environments.
Cool. That's so fascinating.
Yeah, it's good fun. Hopefully we will get some of those certifications soon and can really start driving into some of those environments as well. It's things that like you have to take them very seriously, right? Because this isn't, if we go into a commercial building and we break the air conditioning for a day, there's some mildly annoyed people, right? Building engineer might be yelling at me, but like nobody died in the process of that, right? And if we screw up something in a refinery or in an energy plant, there's actual lives on the line. And those sorts of things, again, when we decide to be read-only at the beginning, a big part of it is in some of those other industries, write capabilities can be pretty dangerous. And so we have to take it very seriously.
All right. Well, death is a good place for us to end off today. Thanks so much for coming on the show.
Such a serious note at the end.
Well, I appreciate it. This has been super educational. So thanks for coming on.
Yeah. Thanks for having me.
All right, friends. Thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.